Hey all, today we are going to switch gears from categorical data and we're going to talk about displaying and summarize quantitative data. So this is part one of two. Today we're going to talk about the different types of displays, and then in the next lesson we'll talk about how we can describe those displays or summarize them, as the title suggests. So I just want to start you off with a data set here. This is quantitative data. We're talking about fourth grade children doing this agility test. And so we're counting the number of lines they clear in 30 seconds. So we have a number of lines per 30 seconds. And so this is different from categorical data because we're not putting our data into categories. Here we actually have values with units. So the question is, how do we display this type of data? So we can't just pile these data entries into categories like we have been. So we have to find different ways to display it. And one of the ways we're going to use a lot is through a histogram. And so in class, we'll create some histograms on the calculator. For now, we'll just talk about this histogram here. I use that data to create this histogram. And what we do is we break the data up into bins. I'll type that out, bins. Because we don't have categories, we can't just pile them into categories, so we have to separate them in some way. And so really quick, looking at this data, it seems to extend from 12 to 29. So we can break these up into bins that are 2 units wide. So here I have a bin that represents 10 to 12. And over here I have a bin that represents 28 to 30, and then we just basically count how many data points are in each bin, and what we can see is the distribution of the fourth graders' agility test results. We'll talk more about how to describe this display in the next lesson, and in class we'll also discuss how to create it. Another way is to create a stem and leaf plot. And so here we have some of the data that are in the teens, some that are in the 20s. And so we can create these stem and leaf plots using a stem of 1 and 2. And down here I have a key that 1/2 is 12 lines per 30 seconds. And it's sort of can show us an interesting picture or the distribution of the data. So this one's a little less interesting because my data doesn't spread out very far. So I have this really big pile here in the 20 to 25 range. But this is just another way to get a picture of what our quantitative data looks like. Sort of similar to sort of like a combination of a histogram and a stem and leaf plot, we have a dot plot. And so I've just taken the data, and we have a numerical axis down here, and we can turn this on its side as well. And I just put a dot for every data point. So that's my 12 data point, over here's my 29 data point, so on and so forth. And we can see how these scores are distributed. It's just another way to visually represent our quantitative data set. It should look relatively close to what our histogram looked like, except here we're not bunching them in groups of 2 or in bins of 2. Here we have a dot for every single data point. And again, in the next lesson we'll talk about how to describe this looking at this picture. The last one is one you might be familiar with, is a box and whisker plot. What's nice about a box and whisker plot is it shows you your minimum value. Let me get a highlighter. It shows you your maximum value. It also shows you the middle 50% of your data right there. And so we can create these, like I just created this one in the calculator, and in class we'll create these together. And again, another way to display quantitative data We'll definitely talk about how to analyze these further, and we'll talk in class about creating them. So we'll take some data sets and create box and whisker plots. So these two ends represent the minimum, the smallest number, the maximum, the largest number. And this box in here is going to represent the middle 50% of our data. We could also make some calculations using our data entries, calculate some important descriptive statistics. The first one being this x bar, that x with the line over it, we call x bar. That is the mean. So the data set that we had, I put into the calculator, created a histogram, created a box and whisker plot, and I also calculated these descriptive statistics. This one right here, x bar, is the mean of our parallel line jumping. These two values down here represent standard deviation. The S is a standard deviation for a sample, which is what we have. We just have a sample of the kids. This Greek letter sigma represents the standard deviation if we had the population of the fourth graders. We do have a Greek letter for mean if we are looking at the descriptive statistics of a population. The Greek letter for that would be this symbol, mu. So when we have a sample, we call the mean x bar. When we have a population, we call the mean mu. When we have a sample, we have the standard deviation s. If it's the population, we have the standard deviation sigma. I like to think about it as the Greek letters represent the things we normally don't have. The Greek is something that might be new to you. Populations are something we don't know anything about. And so we typically have samples, x bar and s. N represents the number of samples we had. So we just had 25 students, 25 entries. And that continues over here. We have a minimum, the smallest number, a maximum, the largest number, and then we have these three values which help us create the box and whisker plot, which we'll talk about more in class. Q1 is the middle of the first 25% of our data. The median is the middle of all of our data. And Q3 is the middle of the upper 50% of our data. So we'll talk a little bit more about these in class when we actually create box and whisker plots together. So it was sort of a brief overview of displaying quantitative data. We're going to create some quantitative data displays together in class, and we'll calculate some of these descriptive statistics that we need. And then in the next lesson, we will talk about how to describe the data displays in terms of shape and spread and center and any unusual characteristics. So again, no questions here at the end. This was simply just an introduction to this. So make sure you come with any questions to class, and we'll learn how to make these data displays.